Okay. A particle of mass 5 kilograms rests on a smooth horizontal table between two vertical walls. Okay. So it's between two vertical walls. Okay, 7 meters apart. So they're 7 meters apart. Here's your wall, 7 meters apart. Okay, it's attached to the left-hand wall by means of a latch string of natural length 1 and elastic consistency of 12 newtons per meter squared. So 12 newtons per meter. Okay, and L0 equals 1. On the other side, it's on the right hand wall, elastic string of natural length 1, so L0 also equals 1, but this one is 8 newtons per meter. Okay, now because the left hand side one is stronger than the right hand side one, the equilibrium distance is going to be over towards the left side of the wall. We'll call this distance D. Okay. So distance D, which means that the remainder must be called 7 minus D, because that's all just left. Okay. Now, last stream by means of how far from the left hand wall is the position of equilibrium? We want to find out what D is. So at equilibrium, the forces left equals the forces right. So I say it's the left hand force is going to be, the form is K times your current length minus your starting off length, your natural length. So what we're going to get is 12 multiplied by D minus 1. Okay, 12 times D minus 1 equals 8 times. Okay. 8 times 7 minus D minus 1, multiply out both sides, you're going to get 12D minus 12 equals 50, wait a second, we don't want that. Sorry, 12D minus 12 equals, we're going to tie that up, it's going to be 6 minus D, so it's going to be 48 minus 8D. Bring all the D's over one side, and we're going to get 20D equals 60, and therefore we're going to divide by 3, and D will equal 3 meters. So D is 3 meters. You bring that back to the top, that means that this one is 3, and this one here should be 4. Okay. By examining the force on the particle when is the distance 3 plus x from the left hand wall, show that it will perform simple harmonic motion. Okay, so what can happen here is the following. It's now a distance of, we know that the equilibrium distance is 3. But the particle, this is the equilibrium distance, but the particle is now 3 plus x away from the left hand wall. So we have to add on a distance x. Okay? So that's now 3 plus x. We know that this was 4 at equilibrium, but now it's missing a distance x, so that one will be 4 minus x from this side. Okay? So the total length of the string attached to the right wall is 4 minus x, while the total length of the string attached from the left wall is 3 plus x. Okay, so what we need to do is the following. We need to find out the net force. Okay. Now, which one's bigger? The force going left or the force going right? FL will have to be bigger. Why does FL have to be bigger? Because we extended it from the equilibrium point to the right, and now it's going to bob backwards and forwards for a minute. So therefore the net force has to be equal to, we're going to use FR minus FL. Why are we using FR minus FL? Because FL is bigger than FR and will give us a negative answer for the acceleration. Remember, in all these questions we're looking for the acceleration to be minus w squared x. Okay? Minus w squared x. Okay? So, net force is ma. The particle is 5 kilograms, so that'll be 5a. equals FR. Now FR is K. It's going to be 12 times the new length. The new length is 3 plus X. The old length is minus 1. Okay, we just drag all this down here because we're not going to have enough room for it. Okay, and then we're going to take away FL. So minus FL, and FL is going to be the force to the left, which is 8 newtons per meter regards to the elastic constant. Its current length is 4 minus X. So 3 plus X. Ugh. Excuse me, guys. I seem to do. I did FL before FR, so that's where I made a slight mistake there. So that's actually FL, and now I'm going to do FR in front. So force to the right is going to be 8 times elastic constant of 8. 4 minus X is its current length, and its old length was minus 1. Okay, scroll down. Then what we're going to get is 5A equals 8 times 3, which is going to be 24 minus 8X. 3 minus 1 is 2, that's going to be minus 24 minus 12X. We're going to get 5A equals minus 20X. A therefore is equal minus 4X. And this is simple harmonic motion with a constant omega equals 2. Do you notice the way the acceleration is in the different direction to the distance? Okay. Next one. If the particle is released from rest midway between the walls, show that the periodic time is pi and find the maximum speed. Okay, midway between the walls. What extension is the midway? Midway is, what's the midway between the two walls? 3.5. The amplitude therefore has to be 0.5 because it's 0.5 away from the equilibrium spot. So what we now know about the next question is, we know that A amplitude equals 2. We know omega equals 2. Okay, so we know the amplitude equals 2 and omega equals 2. The periodic time, T equals 2 pi over omega, which is 2 pi over 2, which is pi seconds. So we know that that's pi seconds. What's the next part of number 3? We have to find the maximum speed. What's the formula for maximum speed? Max speed equals WA, which is going to be 2 times, sorry, A is 0.5. It's not 2, it's 0.5. A is 0.5, so 2 times 0.5, which is 1 meter per second. Okay, next part. Find the magnitude of the force on the particle when its velocity is that root 3 over 2? Yeah. Find the magnitude of the force on a particle when its velocity is equal to root 3 over 2. Magnitude of the force. Magnitude of the force. What would that mean? We'd have to find out. Okay. Our force equation is given to us in terms of x. See the way the acceleration equation is this, guys? Yeah? That's the acceleration equation. If we get the acceleration, we get the force. Notice that acceleration is given to us by the variable x. So what we're going to have to do is find the variable x. Okay? So to find the variable x, we'll do the following. Okay, so part 4. Okay. Phi equals root 3 over 2. The formula is phi squared equals omega squared a squared minus x squared. Then what we do is we scroll down and we say, alright, phi squared, we're going to square that both sides, or sorry, top and bottom, numerator and denominator. We're going to get 3 over 4. Omega was 2, omega squared therefore is 4. A was a half, A half squared is a quarter. Excuse me a moment. A is a half, isn't it? And therefore it's 0.5. Okay. This will be interesting. Okay. Minus x squared. Multiply this out, and we're going to get is 3/4 equals 1 minus 4x squared. Okay. Therefore 4x squared equals a quarter. Okay, x squared equals a 16th. X therefore is equal to a quarter. The distance that this happens is a quarter away from equilibrium. So your extension is a quarter when this happens, okay? So all you have to do now is find the magnitude of the force. And we know that A equals minus a quarter x. So therefore your acceleration must be minus a quarter times a quarter. Your acceleration is 1/16. Oh sorry.
W squared x.
Oh sorry, w squared x. Yeah. Sorry, it's minus 4x. Okay, excuse me. It's not a quarter x, it's minus 4x. So A is equal to minus 4x, which is the equation we had to start. Minus 4 times minus a quarter. A equals minus 1 meters per second squared. Therefore, force is equal to MA. And MA is 5 multiplied by 1. Just take its magnitude, you don't really need the direction, which is going to be 5 newtons. So 5 newtons of force. Alright, guys, this one here. A particle B of mass 5 kilograms is connected by a light elastic string. A light elastic string of natural length 2 meters and elastic constant 140 newtons per meter to a fixed point Q on a rough horizontal surface where the coefficient of friction is 1. P is released from rest at a point A where QA equals 3 meters. Now, you might be a wee bit confused with a system like that, alright? So you just have your vertical line, then you're going to have your elastic string getting stretched. Then at the end of this, you're going to have a body that is attached to a particle. So the particle will be here. Okay, and then you're going to have your forces up and down. So your forces up and down should be your reaction force going up, your weight going down. Now, because it's an extended string, your force is going to, it's pushed past its equilibrium, so it wants to pull it back to the left. Because it wants to pull it back to the left, this means that there must be a force, there must be a frictional force opposing the motion going in the opposite direction, okay? So these are the forces we have at play at the moment. Okay. First and foremost, let's find out what our frictional force is, right? So R equals mg, and mg is 5 times 9.8, which is going to be your 49 newtons. Okay. Friction equals mu R, and mu is, the coefficient of friction is 1. So it's going to be 1 multiplied by 49. The friction therefore is 49 newtons. Now, which way is friction going? Is it a force right or a force left?
Right.
Force right. It's opposing the motion back to the left. Okay? Because it's being pulled. The block is going to move to its left, which means friction always opposes motion. Friction will be going to the right. So your force to the right is 49. Now we got to do our force left. Force left, okay, is once again K times L minus L0. K is 140. Now we have to figure out what L is. It says, but consider the forces acting on P when it's a distance 2.35 plus X. So it's going to be this full distance here. It's going to be 2.35 plus X from here to here. Right, so between the two black dots. Okay. That's its current length. Okay, its natural length is 2, correct? So it's currently, you're extended beyond that as well, okay? So it's going to be 2.35 plus x minus 2. Okay, and that's going to be its force left. Okay, and its force left should be, so it's going to pause this for a second. Okay, so we have 2.35 plus x, okay, so it's going to be 140 multiplied by 0.35 plus x. 140 by 0.35 will get us 49 plus 140x. Now 49 plus 140x. What we have to do next is our net force. Net force equals FR minus FL. We're expecting FL to be bigger because we're told that you're extending it. It's an extension, and you're extending the particle. You're extending the distance to the right, and then you're releasing, and then it goes left. Okay. So what we should get here is 49 minus bracket 49 plus 140x. The weight of the particle is 5 kilograms. So what we're going to get is 5 times A equals minus 140x. Divide 140x by 5 and you're going to get is A equals minus 28x. Now please remember that A is minus omega squared x. We could do a find out what omega is. Omega squared equals 28. You must put in root 28. It's a calculator and you'll find that's 2 root 7. So omega equals 2 root 7. Okay? Now, next part. State the position of the center O of the simple harmonic motion QO. Okay? Particle P is connected by a light elastic string of naturally length 2 meters to a fixed point Q. So this is Q. And what they're asked us to find is where is the center of the motion. Now, to find the center of the motion, we now know that A equals minus 28x. And this is question part 2. When x is 0, A therefore equals 0. Therefore, net force equals 0. Where there's no net force, this is where the center of its, this is where the equilibrium point is. Yeah? So therefore, in the first question where we got the extension, the extension was 25 plus x. That was your total length. But x is 0, therefore the equilibrium point must be 2.35 meters away. Okay? Because if it has no extension, it has no acceleration, therefore it has no force. Any questions? Okay, part 3. Write down the amplitude of its motion. Okay, amplitude of its motion. Once P is released from a rest point A, where QA equals 3. So QA equals 3. So it's going to be 3 meters away in total. Okay? So this means that if it's 3 meters away in total, what you're going to find is this. 3 meters away in total would mean that 2.35 plus x, that's your equilibrium distance, plus your extension to take it out of equilibrium, that total length must equal to 3. Therefore your extension, which is x, is 0.65. Okay? Amplitude therefore must be 0.65 because that's your starting off point. Okay? Next part then is part 4. And what it's asked us to do is asked us to find the periodic time. Is that correct? Yeah? T is equal to 2 pi over omega. And as discussed before, omega is 2 root 7. So it's going to be 2 pi divided by 2 root 7. And that will get you pi over root 7 seconds. Okay, number 5. Okay, question 5. Calculate the time taken by the particle to travel from A to a point 2 meters from Q. Okay, so let's rub out some of the stuff we've had before. Okay, now this is the 2.35 meter mark. Actually, wait, I'll do a bit closer. It's not accurate. Okay, the green mark is our equilibrium position. Okay. The red distance here is our extension of 0.65. Okay? And what I want us to do is calculate the time taken from the particle to travel from A, so this is point A here, to a point 2 meters from Q. So 2 meters from Q is 2 meters from Q. It's still obeying simple harmonic motion. Why? Because it has a natural length of 2 meters. So it's at the very limits of where it obeys simple harmonic motion for, because the string's just got to go slack. Now, what happens is it goes across its 0.65. Okay, it's now at 2.35, and then it goes another, has to travel another 0.35 to the left, doesn't it? For it to obey the simple harmonic motion. So it has to travel 0.35 meters from X. Is that alright? Now, the next part. We can start the calculate the time taken by the particle to travel from A to the point 2 meters from Q. Okay. Now, just have to draw another diagram here. Okay. It's that's our equilibrium position. Okay? And it was 0.65 away. 0.65 meters away. And this 0.65 is known as the amplitude, right? Now, how much of the period does it take to go from here to here? How much of the period does it take to go from here to here in simple harmonic motion? If you travel one amplitude, where do you start from? Sorry, if you travel from one amplitude, how long does it take as a fraction of the entire period? A quarter of the entire period. Because if you start from the extreme point, you go across A, you go across another A, you go back across A, and you go back across another A to be where you begun. You go all the way up and all the way back. So look, basically you start here, all the way over, 2 amplitudes, all the way back, 4 amplitudes. So you're covering a distance of 1 amplitude, which is a quarter of the periodic time, which is 2 pi over square root of 7.
Not pi over 7.
Oh, sorry, just pi over root 7. 1 pi over root 7. Okay? Now, which gives you 0.2968 seconds. So, now all of a sudden, you're in the middle. You're now at the equilibrium point. Okay? And you now need to travel a further 0.35 meters, correct? A further 0.35 meters, okay? So what we need to do next is, we're now starting off at the equilibrium point. Start the clock again from the equilibrium point. So you're not going to use a cos function, you're going to use a sine function. Okay? So x equals a sine wt. So a equals a sine wt. This is at the start, at the centre. Now guys, some of you might say, well look, is x not minus 0.35 because it went 0.35 to the left? But because it's symmetrical, the distance travelled from 0 to minus 0.35 It's the same thing as the distance travelled from 0 to plus 0.35. So it doesn't matter, okay? Friends. Alright, so we're gonna do 0.35, okay? A is equal to 0.65, which is the amplitude. Sine. Omega is what did we say it was? 2 Was it?
Yeah.
2 root 7. Thank you. 2 root 7 times t. Okay. Now we have to figure out what the time taken is. Okay. So the time taken is going to be. We'll just do it all on the calculator here. So what we're going to do is make sure it's in radian mode for a start. So you see your radian mode there. Now 0.35 divided by 0.65 is 7 over 13. We're now going to sine inverse that 7 over 13. Sine inverse answer. Okay. And what we're going to get is 0.5686. So we're going to get 2 root 7t equals 0.5686. We're going to divide our answer by 2 root 7. And then what we get is 0.1075. So t equals 1075. Okay. Now you add both times together. Sorry? Oh. Sorry, excuse me guys. Yeah, 0.1, so excuse me. 0.1075. Now you add the time it takes, so the first time is the time it took to cover the first amplitude. You start the clock from the centre and then you saw how much time it took to take a further 0.35. So we're going to get as 0.1075 plus the other answer, which is 0.2968. Add them together and what we should get is 0.404 seconds. Okay.